Hi guys, so today we'll be taking another question on wave equation. So before I proceed, welcome to Consent Mastering. Please like my videos, share and comment, and click on the subscribe button. Now, this question says a stress strings for which is mass per meter is equals to 5.00 times 10 raised to the power 2 kg per meter is under a tension of 80.0 Newton. How much power must be supplied to the string to generate a sinusoidal wave at a frequency of 50 Hz and amplitude of 6.0 centimeter? I repeat, it said a stress strings for which your mass per meter is equals to 5.00 times 10 raised to the power 2 kg per meter is under a tension of 80.0 Newton. How much power must be supplied to the string to generate a sinusoidal wave at a frequency of 60 Hz and amplitude of 6.00 centimeter? So we are asked to find the power. We are finding the power that must be supplied to the string. Now, in the question, you were giving our mass per meter, which is this, we are given our mass per meter there, which is actually 5.00 times 10 raised to the power 2 kg per meter, and we were given our tension, which is T equals to 80 Newton, and we're given our frequency, which is your F, is equals to 60 Hz, and we're given our amplitude. Yes, we're given our amplitude. In the question, said our amplitude is 6 centimeter. 6 centimeter amplitude. A 6.00 centimeter. And we are asked to find the power. Yeah, this is what we're finding. Now, this is the formula. For this question, this is the formula you're using. The power carried by the wave will be your P is equals to 1/2 mass per meter. This is your angular frequency all squared, your amplitude all squared, and your wave speed. Now this is formula you're using here. This is your mass per meter, your angular frequency, your wavelength, so your amplitude and your wave speed. But we don't have our wave speed. In the question we are not given our wave speed, but we are given what we are going to use to find our wave speed. Now let's find our wave speed first. Wave speed, which is actually V, is equals to your tension divided by your mass per meter. What is our tension? 8 Newton. What is our mass per meter? That is 5.00 times 10 raised to the power 2. 5.00 times 10 raised to the power 2 all squared. Now if you do this, your V will give you, that is 1600 all squared. That is your wave speed will be 40 meters per second. So you have gotten our wave speed now. Now let's put this in the formula. That means our power Now, let me just tell you something about this formula. This formula means that your mass per unit length is increasing. If your power is increasing, your mass per unit length is increasing, your angular frequency is also increasing, your amplitude is increasing, and your wave speed is increasing. Note this, if your power is increasing, that means every other thing here is increasing because they are all proportional to it. They are all proportional to it. So that is it now. But here, we are also not giving our angular our angular frequency. Let's find our angular frequency. Let's find our angular frequency before we can find our power. So let's just find our angular frequency. So that our angular frequency is actually equals to 2 pi f here, 2 pi f. So that means your angular frequency will be 2 pi times f. What is our f? We are given f. They told us our f is 60 Hz. 60 Hz. So your pi is always 22 divided by 7. So you know that. So that means your angular frequency will now be, if you times this together, it goes to give you 377, yeah, radian per seconds. Let me write it. Yeah, omega will be 377 radian per second. So now we have gotten our angular frequency. You cannot find our power then. You cannot find our power. That means our power, you are using this formula, will be equals to 1 all over 2. What is our mass per meter? Our mass per meter we're giving here is actually times bracket 5.00 times 10 raised to the power 2, close bracket, times, what is our angular frequency? This is what we got our angular frequency, 377 all squared, times, what is our amplitude? We are given our amplitude 6.00 centimeter. 6.00 centimeter. Remember, we are going to convert this to meter. Yes, we are going to convert this to meter. So if you convert this to meter first, it's going to be 0.06 meter exactly for your amplitude. So because you are doing with power here, and power you always work with meter, not centimeter in power. So that will be 0.06 all squared exactly. Now what is our speed? We are waiting gotten our speed. What do we got? We got 40 meters per second times 40. So now when you multiply all this is 377, this is 377 all squared. You divide everything, now come and divide it by 2. You're going to have our power will give us 512 watts. Yeah, 512 watts. So this is our final answer. This is our final answer. And what does it mean? It means that we must supply 512 watts of power. We must supply 512 watts of power to keep that wave moving. For the wave to keep moving, we must supply 512 watts of power. That's what it means. So that is the answer to the solution. Thank you very much for watching. Please subscribe, click on the subscribe button, like my videos and comments. Have a wonderful day. And wait for more videos of questions.